All right, today we are going over 7.4 rational exponents. So let's take a look at some rules here. We're going to have two different forms. We're going to have radical form, which will look like something where we have the square root of 25, the cube root of 27, the fourth root of 16. These are all in radical form. It has a radical with it, hence the radical form. The exponent form, in order to convert to exponent form, it's going to have an exponent. And in order to make it into exponent form, we're going to use power over root. So the power, we're going to look at whatever we have underneath the radical. In this case, it's a 25. And this has a power of just a 1, because if there's no exponent or no power written in, it's just a 1. So I'm going to write this as 25, because that's the radicand, to the 1/2 power, because if there's no root written in, then it's a 2. Okay, so this is 25 to the 1/2 is the same as the square root of 25. If we have, which is obviously our square root of 25, we're using the principal root, that's a 5. Okay, the cube root of 27, we'll do that a similar way. We'll take 27, and that will be to the 1/3 power, because power over root, 1 over 3, power over root, which is equal to the cube root of 27 is 3. And the fourth root of 16, that's going to be 16 is our base. The power is a 1 over, and then our root is a 4. So 16 to the 1/4. And whenever we take the fourth root of anything, it's the same as taking the square root twice. So if we take the square root of 16 twice, the square root of 16 is 4, and the square root of 4 is 2. All right, so let's try some of these. So now we need to be able to go back and forth both ways. So we're going to simplify the expression. Simplifying expressions with rational exponents. Rational meaning we can make it as a fraction, a over b. So 125 to the 1/3 power. We're still going to be using our power over root here when we convert it to radical form. That will make it easier. So right now it has a fraction, so it's in exponent form because it has an exponent. So I'm going to change it to radical form by doing power. My power is a 1, and the root is a 3. So this is the same as writing the cube root of 125. And the cube root of 125 is 5. This one here, if we look at this, we can do this two different ways. Notice we have the same base. And we know that if we have the same base, we can just add the exponents. But if we did not notice that, we can convert it to radical form. So 1 over 2, the power is a 1, and the root is a 2. So this is the square root of 5 times the square root of 5. And we know if we have the square root and the same radicand, we just get the radicand. And that's because this is the square root of 5 times 5 is 25, which is just a 5. The other way we could have done this is we could have said I have the same base, so I'm going to keep the base, and I'm going to add the exponents. 1/2 plus 1/2 is a 1, and 5 to the first is just a 5. Okay, this one here, 1 over 3, or power over root. Your power is a 1, your root is a 3. This is the cube root of 10 times the cube root of 100. So if they're both underneath a cube root, we can multiply the radicands. 10 times 100 is 1,000. And the cube root of 1,000 is 10. So for this kind, if we have the same exponent, then you can multiply the bases and keep the exponent. Okay, continuing on here. We have 16 to the 1/4. We just did this one before. So power over root, we have the fourth root of 16. If we just take the principal root, meaning the positive value, I'll just do the fourth root of 16 or the square root of 16 twice. And I get the square root of 16 is 4. Square root of 4 is 2. This one here, it's similar to both of these. We have the same base, so we can keep the base, add the exponents, or we could write it as the square root of 2 times the square root of 2, which is the square root of 4 or 2. This one, we have power over root, so square root of 2 times the square root of 8, and then we multiply them. The square root of 2 times 8 is 16, and the square root of 16, the positive value, is a 4. All right, moving on here. So let's take a look at this. We're converting to and from radical form. Okay, write the exponential expression in radical form. So right now, we are going to take 25 to the 3 halves, and we're going to put it in radical form, because right now it's in exponential form, because it has an exponent. So we're still going to make this is the power, your 3 is your power, and the 2 is the root. So we have the square root of 25 to the 3rd power. You can write it like this, or you can write it like this. Either way is fine. I would recommend this way, especially because once we start solving these, you're going to want to take the square root of 25 first and then cube it. Okay, this one here, we have power over root. So the root is a 5. We keep our base of x, and that's cubed, because our power is a 3. This is good, or you can write it as like this. Either way is good. This one here, okay, so the first thing we need to do is we need to get this negative out of the exponent. So we should all remember that x to the negative 1, if we have a negative exponent, in order to get rid of that, we need to bring this part that has the negative exponent to the denominator. So if I bring that down, I'll have 1 over x to the first, or just an x. So in order to get rid of this negative, I need to bring this entire thing that has the negative exponent down to the denominator. So I'll be left with 1 over y to the 2.5. And all that did was it got rid of my negative in the exponent here. Okay, so now what we're going to do is let's convert 2.5 to a fraction. So we know 2.5 is 2.5, and then we can change this mixed number to an improper fraction by going 2 times 2 is 4, and 4 plus 1 is 5 over 2. So this is the same as writing 1 over y to the 5 halves power. Okay? And then that will be power over root. This will be the square root of y to the 5th. You can leave it like this unless it tells you to rationalize your denominators, and then we would have to do that. The other thing is we can take out a perfect square here. So to do that, to take out the perfect square on that, we would take 1 over the square root of y to the 5th, can actually be broken up as 1 over the square root of y to the 4th square root of y. And that's because in order for it to be a perfect square, the exponent has to be a multiple of our index, which is a 2 in this case. So it has to be a multiple of 2. 2, 4, 6, 8, all of those. And then we'll use our power over root again. So 1 over the square root of y to the 4th is y squared. And then we just rewrite the square root of y. So this is good. And if we want to go one step further and actually rationalize our denominator here, then we could take that 1 over y squared square root of y squared square root of y, and we can multiply the top and bottom by the square root of y in order to get rid of the square root in the denominator, which will be rationalizing our denominator. So this will leave us with the square root of y, because 1 times the square root of y is square root of y. And we know our rule of if I have the square root of y times the square root of y, I'm left with just a y. Okay, so this is y squared times Square root of y times the square root of y is just a y. So we get the square root of y over y cubed. This is simplified, and the denominator is rational. All right, let's take a look here. So for this kind, now we're going the opposite way. So for this, now we're going to write the radical expressions in exponential form. So right now they're in radical form because they have a radical. So again, we're going to use power over root. So we keep our base a, and then we do our power, which is 3, and our root is a 2. If there's no number written in, then the number is a 2. So 3 over 2. That's it. Okay, this one here is a little bit different because notice we have a square root, we have b to the 5th, and then it's squared again. So we can remember a couple of rules here. The first thing is you can notice that a square root and a squared are going to cancel out. If you didn't remember that, then you need to remember that if you have an exponent that is inside and outside, then really you're multiplying them. So this is really the square root of b to the 10th. And then we can do power over root. So 10 over 2 is really b to the 5th. So that's one way to do it. The other way is to see that the square root and the squared will cancel out, and then you're just left with b to the 5th. Same thing. All right, moving on. Let's take a look here. A little bit more practice with these. If we have y to the negative 3 over 8, we're going to bring this down to the denominator to get rid of the negative exponent. So I have 1 over y to the 3/8. And then we'll do power over root. So this is 1 over, our power is 3, and our root is 8. The 8th root of y cubed. Okay, we can leave it like this unless it wants us to rationalize the denominator. It doesn't specify that here, but it's always a good idea to do that. We'll leave that for now. Okay, z to the 0.4. So we have to remember to convert 0.4 to a fraction, so we move the decimal over one time. We're left with a 4 over 10. I put it over 10 because I moved it one spot to the right. Reducing 4 over 10, a 2 goes into both of those, so I'm left with a 2 over 5. So this is the same as writing z to the 2/5. Okay, and writing that in radical form, we do power over root. My root is a 5, 5th root of z squared. You can write it like this, or you can write it as the 5th root of z squared with squared on the outside. Either way is good. Okay, these are going over some properties here, so make sure you know all of these properties. If you're multiplying and you have the same base, we add the exponents, n plus n. Okay, for example, if I have a squared times a cubed, that would be a to the 2 plus 3, I have a total of 5 a's, a to the 5th. If there's an exponent inside and outside, you multiply them. For example, if we have a squared to the 3rd, you multiply them. A to the 2 times 3, which is a to the 6th. And we do that because, coming over here, this is saying that we have 3 of them. Look, a squared, and we have those 3 times. So you can really go back to this property where you're adding your exponents. 2 plus 2 plus 2 is a to the 6th, either way, or just multiply the exponents. Okay, if you have parentheses and there's an exponent, both of these are to the m power. For example, if we have xy squared, then this means I have x squared, y squared. Or let's say I have 3x squared. Then this means I have 3 squared x squared, which is a total of 9x squared. This one here, a to the negative m, we know that we just bring this down to the denominator, 1 over a to the m. For example, if we have 2x to the negative 2, we only bring the part down that has the negative exponent. So this will be a 2, because we leave the 2 in the numerator, because that does not have a negative exponent. We bring this part down with the negative exponent, we have x squared. This one, if we have the same base and we're dividing, we subtract the exponents. For example, if I have x to the 5th over x to the 3rd, I keep my base x, I subtract my exponents, and I get a total of x squared. And then finally, this is similar to the multiplying one. If you have a over b and it's in parentheses to the m, they're both to the, this should be a b, they're both to the m power. For example, if I have 3 over y to the 4th power, that means I have 3 to the 4th power over y to the 4th power. If I'm taking something to the 4th power, I really just square it twice. So I go 3 squared is 9, 9 squared 81. So 3 to the 4th is 81 over y to the 4th. Those are our properties of rational exponents that we need to know. So make sure you go over those. Okay, moving on. Okay, we'll do a couple of these and then we'll get into ones that are a little bit longer. Let's see here. Let's try this one. So in order to simplify this, we want to use power over root. So my 4 is the power and the 5 is the root. So I have the 5th root of negative 32 to the 4th. So I'm going to take the 5th root of negative 32, meaning what number, when I multiply it 5 times, will give me negative 32? That's a negative 2. Negative 2 to the 4th power now, because I said the 5th root of negative 32 is negative 2, and then I take it to the 4th power. Like we just said before, if I take something to the 4th power, I really square it twice. So negative 2 squared is 4, and 4 squared is 16. So this is simplifying the number. So we get an actual value. Okay? This one here, 4 to the negative 3.5. So let's change negative 3.5 so that it's going to be a fraction. So we can first bring this down so we get rid of the negative. So this is 1 over 4 to the 3.5. So if I'm changing 3.5 to a fraction, that's 3.5. Changing it to an improper fraction, I go 2 times 3 is 6. 6 plus 1 is 7 over 2. So this is 1 over 4 to the 7 over 2. And then we use power over root. So power is 7, root is 2. This is the square root of 4 to the 7th power. Okay, so we'll take the square root first. So we'll do the square root of 4. Because you're going to do the square root whenever it's a perfect square. If it's a perfect square, then do that first, and then you'll do the exponent. Okay, so this will be 1 over the square root of 4 is a 2, and 2 to the 7th, well, we know that 2 to the 5th is 32, and then we multiply it 2 more times. So 32 times 2, 64, 64 times 2, 128. So this will be 1 over 128. That's this one here. All right, let's try another one. How about this one here? Let me change colors. Okay, so first thing we always do, get rid of that negative exponent. So this is 1 over 25 to the 3/2 power. Continuing on, we have 1 over, we use power over root. Square root of 25, and then that's going to be cubed. So I have 1 over, the square root of 25 is a 5, and then we do 5 cubed. 5 cubed is 125, so 1 over 125. Okay, and then this one right here, we do power over root again. So I have, my power is 3, the root is 5, so this is the 5th root of 32. And the power is a 3, because power over root. So the 5th root of 32 is a 2. and then we have to cube that. 2 cubed is 8. There we go. All right, let's do ones that are a little bit longer but not much more difficult. So this is using all of our properties now. So what we can do here is it's saying that this is in parentheses. So that means that they're both going to be to the negative 3/4 power. So this means we're going to have 16 to the negative 3/4 power. And we're going to have y to the negative 8 times, if we have an exponent inside and outside, we have to remember that we multiply them. Okay, so for this one here, we have to multiply these exponents out. So if I have a negative 8, I'm going to write that as a negative 8 over 1 times negative 3 over 4. Okay, we can simplify this. A negative times a negative is a positive. 8 over 4 is a 2. So those will cancel and that will become a 2. 2 times 3 is a 6. Okay, so this is really 16 to the negative 3/4 times y to the 6, because when I multiplied these out, I got a 6. The other way you could have multiplied them out, negative 8 over 1 times negative 3 over 4. You could just multiply the numerators. Negative 8 times negative 3 is a 24 over 1 times 4 is a 4. 24 divided by 4, we get the same thing, 6. Okay, so now we notice we have a negative exponent here. So the part that has the negative exponent, that's the part that gets brought down to the denominator. So we leave the part that does not have a negative exponent, and we bring down the part that has the negative exponent, and it'll make it have a positive exponent. Now we simplify by doing power over root. So we have the 4th root of 16, and then our power is a 3 cubed. So we have y to the 6th over the 4th root of 16. Remember, we take the square root twice. Square root of 16 is 4. Square root of 4 is 2. So this is a 2 cubed. And then our last step here, that is going to be, y to the 6th, that doesn't change, over 2 cubed is an 8. There we go. Okay, and the more we do these, the easier it will get, just like all math problems, right? Okay, let's try this one here. So again, similarly, we have to do, both of these are to the negative 1/3 power. The first thing that you can do is actually get rid of this negative exponent by bringing everything to the denominator. So we have 1 over 8x to the 15th, in parentheses, to the 1/3 power. Now we can bring both of them to the 1/3 power. So this will be 8 to the 1/3, and then x to the 15 times 1/3. 15 over 1 times 1/3. 15 over 3 is 5. So this is x to the 5th. Okay, and then we can do 8 to the 1/3. We use power over root again. That's the cube root of 8 times x to the 5th. And then we take the cube root of 8. Cube root of 8 is a 2. And then we bring down our x to the 5th. And that's it. Okay, obviously there's different ways to do these problems. The book will show you another way. But we're going to stick with power over root. So just to show you this way with using power over root, which is what we've been doing, we'll just do this one. So negative 32 to the 3/5. We're going to stick with power over root. My power is a 3, my root is a 5. 5th root of negative 32 to the 3rd power. The 5th root of negative 32 is negative 2, and then we cube it. Negative 2 cubed is negative 8. Okay, because negative 2 times negative 2 times negative 2 is negative 8. And that will do it. That is 7.4. Rational exponents. Thanks for listening. Do your notes.